Hey, today's manufacturing minute is going to be much longer than a minute. Hi, this is Gray, and today let's look at minimizing the cost of inspection of your incoming supplies. Now, there will be some math involved, but not a lot because we don't have a lot of time. The idea for this comes from Dr. W. Edwards Deming. Specifically, it's detailed in his book, Out of the Crisis. And it goes along with the third of his 14 points, that is to cease dependence on mass inspection to achieve quality. Now, before we start, note what that point does not say. It doesn't say cease inspection. What it says is to cease dependence on mass inspection, because a lot of times we end up spending more to inspect than we need to. And that's what this manufacturing minute is about. It's about what he called the KP rule. And it's possible to lose money doing too much inspection, but the KP rule allows us to decide whether or not inspection is required and how much. It's only one part of this, and we can't even get into all the nuances of it in a single episode. It's in chapter 15 of this book, if you pick up this book. But let's start with a simple case. We have one part that we're going to install into an assembly, and it's going to go down the line, and at the end of the line we're going to check out that assembly, and if that one part was bad, that whole assembly is bad, and now it has to be taken apart and fixed. And the question is, do we test that one part or do we not test that one part based on the lot that comes in? So the first thing we have to do is estimate some costs. So let's say we let this is the KP rule, so there will be K's and there will be a P. So K1 is going to be the cost to inspect a single item. Now, you have to look at what kind of inspection you're doing. Is it a simple visual inspection? Does it require a functional test that requires test apparatus? And all of that is going to go into the cost of inspecting that single item. K2 is going to be the cost that you incur if the assembly fails because of that item. Consider that you're going to have to move it off the line and back into a test bay or somewhere where you can troubleshoot it, where you can take it apart, where you can remove or replace or repair the part that's failed. Then you have to put it back together. You have to test it again before you send it off to your customer. So you have K1 and K2. And K2 will always be greater than K1, so K1 over K2 will always be a fraction, and we'll work with that fraction. So then you need one more thing. You need the P. You need the average proportion of defective items in the incoming lots. Now, this requires some history, some testing, probably some sampling, some records of the vendor's quality. And that in and of itself better be in statistical control, or you can't really be confident of the future results. And the KP rule compares the cost ratio to that defect proportion. And the question is, how does P relate to K1 over K2, and what does that tell us? Well, in the simplest cases, if the proportion defective is less than K1 over K2, it is actually best not to inspect any of the incoming lot, because you're just wasting the money that you spend inspecting. On the other hand, if the proportion defective, if P is greater than K1 over K2, it's actually best to inspect 100% of the lot of incoming items, because the cost of failure is too high to forego the inspection. Let's consider a quick example. Let's say that you've calculated the cost of inspection and you figured that it cost about $1.25 to inspect one item. And that after it goes through the process and the assembly fails, that item is in, that K2, the cost to rework that assembly is about $650. So if you take the $1.25 it costs to do that inspection and you divide it into 650, you get 0.0019, or just under 0.2%. So if your incoming quality, if the incoming lots of items are such that the proportion that is going to be defective in there is less than that, then you would need to do no inspection at that point, because doing so would add a cost that's not necessary. But if your proportion defective is greater than that 0.19%, then it's better to inspect all of those items to catch that defect before it gets put into an assembly. I said before, this is just the simplest case, and there's a lot more in chapter 15 of Out of the Crisis, so you really need to get that and study it. There's no way to summarize 60 pages of theory and explanation and examples in just a few minutes. And don't get fooled by the idea that you might be able to do no inspection of a particular thing. One of the things that the chapter says right here is the rule for no inspection does not mean to drive in the dark with no lights. I love that line. You should always have information that tells you what the process is doing, and should gather that information in the smartest way possible. But no matter what kind of inspection that you do, whether it's all, some, or none, nothing beats working closely with your supplier to improve the quality they send you. Just in the same way that you should be continually improving the quality of what you produce in your factory. So that's it for this extended version of the Manufacturing Minute. Thanks for sticking with us, and keep doing what you're doing, keep making what you make, but keep making what you make better. Thanks a lot. Have a great day.